Today's lesson is negative and zero exponents. Our goal is that we can simplify expressions with negative and zero exponents. Negative exponents. Consider the expression 4 to the 4th power over 4 to the 6th power. This might look more like 4 to the 4th over 4 to the 6th. Wish these were easier to type. Based on what we learned about division of powers, how would we write the expression as a single power? It would look like this, right? So we factor out what we can. So all 4 of these would be gone. All 4 of these would be gone. We'd be left with 1 here and 4 to the 4th on the bottom, or 1 over 4 to the 2nd. Okay, so 4 to the negative 2nd, or 1 over 4 to the 2nd power. So that is what that simplifies to. Okay, do you see this? Right here, this is important. Okay, 4 to the negative 2nd is equal to this right here. It's a negative exponent. And it does not mean, never mind, I'm not going to expand that because it's kind of confusing. It does not mean 4 times negative 2. Okay, it means it has a fraction. All right, so our general rule here is so the general rule would be that if we have a negative exponent, it is rewritten. I thought I should have that working. Negative exponents are rewritten as fractions with a numerator of 1 and the denominator is a positive power. Okay, so now let's practice this. We have 5. Again, I want to rewrite this. I keep doing this with you guys. So we've got 5 to the 5th power over 5 to the 8th power. So as we learned, we're going to subtract our fractions, our powers, so our exponents. So we now have 1 over 5 to the 3rd, right? Okay, and if we are evaluating that, it doesn't say to write it as a product of powers, so I'm assuming at this point that I am supposed to take this all the way out to 1 to the 125th power, okay? Another way this could have been started out would have been 5 to the negative 3rd power would be another way that would have been written. Okay, so next, we're going to rewrite these expressions using only positive exponents. So, we've got 20 r to the negative 5th over 4 r to the 3rd. I'm sorry, negative 3rd. So, now we've got to simplify this. Okay, so that 20 divided by 4 can happen, and we're going to be left with 5. That's the easy part. Now we've got negative 5 minus 3, which is negative 5, plus negative 3, which is negative 8. Okay, so we've got then 5 on top, and if we take our base of r, it's going to stay on the bottom, and it's going to be an 8. And I believe we are completed then. Okay, hopefully that makes sense to you all. Because I simplified my negative 5 minus my 3 minus my negative 3. Ooh, no, minus my negative 3. Hold on, now let's look at this again. Let's see if I've got that right. Minus becomes plus 3. So now it's just negative 2. So, okay. So now it's just r the second power, because it's still a negative exponent. Okay. So, again, as I always say, if you have questions, make sure you bring them to me when you see me next. Okay, on to our 0 exponents. Okay, so now let's fill in this chart. Working backwards, we've got 4 to the third, or 3 to the fourth, sorry, is 81. 3 to the third is 27. 3 to the second is 9. 3 to the first is 3. 3 to the 0 is 1. 3 to the negative 1 is 1 over 3. And 3 to the negative second is 1 over 9. Okay? How are the numbers changing in the second row as we decrease each exponent by 1? They're a third. They are a third of what they were. And a third because that's our base, right? All right, so let's look here. So here we've got 16, then we have 8, and then we have 4, 2, 1. We're cutting each one by half, right? And then we've got 1/2 and 1/4. Okay. What do you notice about the numbers in the second row when the exponent is 0? So we're looking at the second row. So we're looking at these right here. So when the exponent is 0, it is 1. So it is 1. So therefore, the simplified version, let's extend this so you can see, of any number raised to the 0 power is 1. All right, so that is our lesson. Again, if you have questions, please come see me. You'll have time in class next time you see me. Thanks for watching.